Okay, so let's start with the question combination sum 3. So, of course, revisiting it is just learn the concept of it and tried solving it. So basically, what we have to do is we have to take numbers from 1 till 9, and after taking numbers from 1 till 9, what we have to do is that we have to make sure that we follow the k and the n constraints. So basically, if k is 3, that means we can take only three numbers to get what n is, that is if it's 7. So we can only use three numbers to get 7 from the range uh, 1 to 9. So yeah, that's pretty much the question. Now the thing is that same combinations can't occur twice. It should be appearing only once, and that's it. The combinations can be returned in any order. It's not necessary to have a particular order. That I mean, here 2, 3, 4 can be before, but yeah. So let's start solving by using the prerequisites of combination sum 1 and 2. Having a helper function, having it void, yeah, and then it won't be returning anything. We'll have int k for short. We'll have int n, of course. We'll have a start index, so int start. So like we'll traverse through these numbers, so we'll have int start. So it's like we take 1, so we start from 1, and then either we remove it, either we pick it, or we not pick it. That's it. Either we pick or we not. So we'll have int k, that is total numbers and elements we can use, and the summation in start, and then we can have our lists. Yeah. So we can have list integer uh, parent, and then we can have list and a list and integer, that is result. I guess that's pretty much it. So now we can have our conditions, the base cases. So what can be the base case? Base case can be if our n is 0, if n is 0, yeah, if n is 0 and k is 0. What about that? Yeah, let's what? Let's try this. Yeah, let's try this. So if this is the thing, if this is the case, all right. So what we can do is we can just simply do we can simply add what do we have here? Result dot add um, new. Nah, we can just add current to it. Let's not think much. Let's form the blueprint of the code. We can have now. Then we can have another case to verify. The moment either of them becomes less than 0, we'll have to break. We'll have to stop right there. So if n less than 0 or k less than 0, we break. Yeah, yeah, simple, easy stuff. Now we can have a for loop wherein we can have int I, that is to start I less than uh, or equals to 9, I plus plus. Basic for loop. We'll have start as 1. Yeah, not 0 but 1. We'll have start as 1. And then what we will be doing is that we will be adding, we'll add the first element. So current dot add I, yeah, we'll add it, we'll call the recursive, then we'll have a recursive call, that is we'll call helper with k minus 1, uh, n minus I, start plus 1, uh, yeah, wait, should I call start? I'll name it, I'll name it as 0. So initially it will be 0, so I'll put that thing as I. Yeah, then same current, current, and result. That's it. So now we'll add call, get the recursive call. But what if we don't want that number? Like, yeah, we wanna backtrack. So we'll remove that. So um, current dot remove. Is that the right word? Let's see. Current dot remove. Current dot um, length minus 1. I hope there is no syntax error right here. Let's see. Let's see. So this is our loop. Here we will call helper with our k intact, with our uh, n, with our um, start as 1, with our current, and with our result. Yeah, but let's create them. Yeah, let me just copy paste. New RLS. Um, then, yeah, yeah. So basically, we can just return result. Mhm. Uh, Yep. How does that look like? Private void helper int k. I mean, I have it back in my chat GPT just to verify, but let's see. Let's see if the logic fits. Int k starting from 1, current and result, everything added, result dot add current, return, stops, result dot add current, will returning the result. If n is 0 and k is 0, that's the base case. If any of these things happen while the execution, stop right there. I starts. Let's see. Okay. Error. Outside the switch or the loop. Cannot find the symbol. Yeah, I guess it's size. Yeah, only this one. Just have a return. Okay, what's the error? Alright, it's returning empty arrays instead of the answer. Let's fix that. When I have a current down here, I guess it's gonna give an error again. Yeah, we if we have it already, then why have it right here? That makes sense. Why is it? Maybe because of this. Uh, oh wait, this current is initially empty. New array list current. How about that? Yeah, works. So initially that was empty. So we needed to figure out uh, another way. So yeah, that was empty. The current because yeah, if it's not having any value, it's gonna give empty. So we made a new current. So to add to the result, not the generic one, the ones that empty. So yeah, if for the whole thing is gonna go current dot add current dot blah blah blah, and everything is gonna happen, and then yeah, we'll add the if whenever this gets this, we'll add the new current, and that's it. I guess. Let's see. Okay, works perfectly. So